Well, here we are at the end of our unit of study 2.1 on the introduction to Newton's laws, and I want to give you a preview of unit 2.2 just because these two units tie together very carefully. In fact, unit 2.2 is called applying Newton's laws. So the main elements that we'll be investigating in unit 2.2 are how to deal with frictional forces, forces of fluid resistance, including air resistance, right? Fluid is either any gas or liquid, anything that flows. So when I say fluid resistance, maybe we want to think of that more as air resistance. And we'll also have an investigation of centripetal force. So one idea I want to preview when it comes to friction is there are two types of friction. Sometimes friction is there to hold objects at rest. In that case, we refer to it as static friction. When an object is moving and two surfaces slide against each other, then we say there's friction of motion, or better yet, what we call kinetic friction. A lot of similarities between static friction and kinetic friction, but the two are treated somewhat differently, and we'll see that when we get into Unit 2.2. Air resistance is unique from friction in that it's a velocity-dependent force. Think about if you ever put your hand out of the window of a moving car just to feel the air resistance at high speeds. Notice how much different it feels driving at 70 miles per hour on the freeway than it would driving 10 miles per hour through the school parking lot, right? The force of air resistance is very much dependent on how fast the object moves through the fluid. Friction isn't like that. When two surfaces rub against each other, the sliding friction or kinetic friction is the same whether the object's going 10 meters per second or 20 meters per second or 30 or so on. Okay, and lastly, a preview of centripetal force. We derived in our study of two-dimensional motion a formula related to uniform circular motion. I think one example we had is if a car is driving around on a circular racetrack and has a velocity that points tangent to the circular path. If we happen to know the radius of the circular path and this tangential velocity, then there's an acceleration that must point toward the center of the circle, which is why we refer to it as centripetal. And that acceleration is equal to v squared over r. Well, now we have Newton's second law that says the sum of all forces is equal to mass times acceleration. So if there's a acceleration that points toward the center of the circle, there must also be a force pointing toward the center of the circle. And so a centripetal acceleration leads to a centripetal force. There must be a formula then for centripetal force that's equal to m times v squared over r. And we'll find a lot of different example problems for objects moving in circles, and we'll continue to make free body diagrams, and often the combination of forces in our free body diagram will be set equal to some sort of a centripetal force. So that's all for now. Thanks for paying attention for this unit of study 2.1 on the introduction to Newton's laws, and you can start tuning into the lectures on unit 2.2, applying Newton's laws. Thanks for watching.